This video will show some examples of using the log rules to manipulate expressions and to solve exponential equations. So this first problem asks you to expand each logarithmic expression, and we're going to use this rule right here that has the product of two values inside of a logarithm. So according to the rule, we do the log base 2 of 5, because that's the first value in the product, plus the log base 2 of x to the third power. Now that's pretty good. We use this log rule, but we can also use this log rule that has the log of an expression with an exponent in it, and you can bring that exponent down in front. So we're going to do one more thing to this expression just so that we can practice using all the log rules possible. And this 3 can come down in front and become the log base 2 of x. Okay, so number 2 is very similar to number 1. If you are a little unsure here, you should pause the video right now and try this yourself and then start it back up. Okay, so pause, try it yourself, and then hopefully you did that and you're back with me here. So this is the log, and since there's no base showing, it's base 10, and that's fine. You can just do, you don't have to write the base, or if you'd prefer, you can write the base. So but if you do write it, it will be base 10. So log base 10 of 7 plus log base 10 of x to the 4th. And then the log of 7 will just stay, plus 4 times the log of x. Alright, and then number 3 is a little more complicated. It's got a division problem in it, which means we're first going to use this rule that has the log of a quotient. And so let's rewrite it first as the log base 6 of 2x minus the log base 6 of y cubed. Alright, then looking just at this part, that can become the log of, since 2x is a product, you can split that into the sum of two logs. So that will become the log base 6 of 2 plus the log base 6 of x minus, now this one has the base and an exponent here within the log statement, and so we can use this rule. Here's the base of an exponential expression, there's the exponent, and that exponent can come down in front. So this 3 can become 3 times the log base 6 of y. Now, I don't know if you noticed or not, but I'm trying to be very careful about always putting these parentheses in. Over the years, I have found that students that struggle with logs, that being very careful with these parentheses can make things a little more clear for them, what it is that you're taking the log of. If you wrote this with none of these parentheses, it would mean the same thing, but it would be harder to tell when the log stopped. Like right here, if it said log base 6 x minus 3 log base 6 y, it's kind of hard to tell where the log stops and starts, and I think that that expression is much more difficult to read. So I would stick with always writing the parentheses. And some textbooks do that always, and some textbooks do not. But your graphing calculator, if you use a TI, will always open a parenthesis before you put in a log expression. Alright, so this one we're going to use the rules backwards comparatively to number 1 through 3, and we're going to try and write these as a single log. The directions say condense the logarithm expression. They could also say write the value, write the expression as a single log. So first I need to get this 1/2 up out of the way, because I can't use this rule if there's any values in front of the logs. So I'm going to take this coefficient that's in the position of this r, and I'm going to rewrite it up here as the exponent. So this will become log base 7 of x to the 1/2 power minus log base 7 of 5. Now I have the difference of two logs, and so I can write that as the log of a quotient. And this x to the 1/2 power, it's hard to read my little 1/2 there, but remember the 1/2 power is the same as the square root. That's a little easier to read, so I'm going to rewrite it that way. If you had left it to the 1/2 power, that wouldn't be incorrect. I just look for every opportunity to help you remember that the 1/2 power is the same as the square root. So I prefer to write it that way, but either way would be correct. So this one, similar skills, so you might want to pause the video and see if you can figure this out on your own, and then start it again to check. So first thing, I'm going to bring the coefficient up as an exponent. And bring the coefficient up as the exponent. Now as I stop and look at this, I see that I have the sum of two logs, which means that I can rewrite it as the product, as the log of one product instead of the sum of two logs, using the first rule up here. So this will become the log of x cubed, it's a terrible looking 3, times the log of x cubed times y to the 9th. Write your parentheses. All right, moving on. This one, log base 2 of 9, doesn't need to change, but the 1/2 should come up as log base 2 of y to the 1/2. I would leave the minus here. Think of this as subtracting a positive 1/2. I think it's a little easier. And then you'll take care of the minus by choosing the correct log rule. So now that I have the subtraction of two log expressions, I can write that as a single log with a quotient. And again, the 1/2 power could be written as the square root. Okay, so moving on to number 7. This is definitely a new type of problem. We are looking for the exponent here. One way to solve this problem, which is indicated here in the directions, is to take the log of both sides. The same way that if you had a quadratic expression on one side, that if you had, say, x squared equals 9, you could square root both sides. We can log both sides. So let's see what happens if we do that. This is not the only way to solve this problem, it's just the way that you're being asked to solve this problem right now. So if you take the log of 5x, 5 to the x, and the log of 3, and notice the use of parentheses here. I think that is a very important step there. Bring this x, now that I've got this, I can bring the x that's in the exponent down in front of the logarithm using this rule here with the exponent and the coefficient. So the x can come down, and then that's the key to making this problem work, because now the x is out of the exponent and I can solve it. So to get the x by itself, I can just divide both sides by log 5, since log 5 is just a number, and get log of 3 over log of 5. And then you could put that into the calculator to get the decimal expression for it. So if we put in the log of 3 divided by the log of 5 and press enter, you get the decimal value of this expression. So we'll round it to, say, 3 decimals, 0.683. And then notice if you take that answer and do 5 to that power, second answer, and press enter, you will get the 3 that is in fact to show that that is in fact the solution. So let's try another. If 2 to the x is equal to 11, then you take the log of both sides and you get log base 10 of 2 to the x is equal to log base 10 of 11. Now technically you can use any base you want when you go to take the log of both sides, but since our calculator has a log base 10 key on it right on the front of the keyboard, that's the easiest one to use, at least for now. So we take the log of both sides and we get this, and then bring down the exponent. That's what I did on this step. So this x that was up here becomes x log 2, and then divide both sides by log 2, and you get this expression, and the decimal value of that is log 11 divided by log 2, and you get 3.459. Is that right? 3.459. Okay. So last one, the algebra here is a little more difficult because there's an x plus 2 in the numerator instead of just an x. So let's see how that goes. It starts the same. We'll take the log of 3 times x plus 2 is equal to the log of 150. And then the whole exponent, the x plus 2, can come down in front. And then you'll still have the log of 3 is equal to the log of 150. And then divide both sides by the log of 3 is the easiest way to deal with the next step. I know I'm running out of room on the bottom of the screen here. I'd prefer to stack this fraction, but I'm going to write it this way. And that'll be the log of 3. And then to get your answer, you'll just subtract 2 from both sides. So your answer will be x is equal to the log of 150 divided by the log of 3 minus 2. That will not be part of the fraction at all. So let's look at it on the calculator since I'm out of room on the bottom of the screen there. So it would be log of 150 divided by log of 3, and then get that expression and then subtract 2. Now the order of operations will do the division before the subtraction, so I can do it all on one line and press enter, and the answer to my equation here for the last one is 2.56. Hope that helps. Good luck on the homework.